Hello guys, in this video we're going to talk about worksheet 10.2a level 1. You're learning two new theorems about circle. The first one is line from center, perpendicular to chord, bisect chord. So it's quite long, but you can remember like this way. There's a line from the center, which is going to be perpendicular to the chord, and then it's bisect the chord. So first of all, we're going to line from the center all the way to the chord, which is perpendicular to the chord. Then we can say that this chord is being bisect. Okay, so which means that if we have OM is perpendicular to AB, so this thing happened first, then we have the chord is being bisect, so that AM is equal to BM. And the second theorem is the line joining center to the midpoint of the chord is going to perpendicular to the chord. So if we have a line joining from the center to the midpoint, which is the midpoint of this chord, which means that AM is equal to NB, so that this line joining to this AB is going to be perpendicular. So this one is actually the first thing happened is AM is equal to BM. So it's actually just the reverse of the first theory. So if we have AM is equal to BM, then we can say that the OM is perpendicular to AB. So there's two different theorems, but actually it's quite long, but actually they're just reverse each other. So again, so the first one is, firstly, we have the OM is perpendicular to AB, then we have the bisect chord, so that AM is equal to BM. For the second one, we first have the AM is equal to BM, then we can say that the OM is actually perpendicular to AB. Alright, so for the first questions, we have that the AM is equal to 6, and then we have a perpendicular line. So we can use our first theorem, the line from center perpendicular to the chord will bisect the chord, so that the AM is equal to NB, which is 6 cm. We have the AM is equal to NB by using the first theorem. So for the second theorem, you can see from the circle, the AM is actually equal to NB, AM equal to BM, so that we have the AB is perpendicular to OM. When this is perpendicular lines, which means that the angle Y is going to be 90 degrees. So for second one, it's using the Pythagoras theorem. So if you don't understand, I will remind you right now. So Pythagoras theorem means that you have a right triangle first, and then the side opposite to the right angle, we call it as the hypotenuse, and then the two sides here is going to be the adjacent. Sorry, this is going to be the opposite, and we have the adjacent here. Okay, so basically if we have the opposite is the A, adjacent is the B, hypotenuse is the C, then we have, by using the Pythagoras, we have A squared plus B squared is going to be equal to C squared. So that's what Pythagoras said. Alright, so in this question, we have OM is perpendicular to OB. As this is given by the questions, we have OM perpendicular to OB, so that we can say that AM is here, AM is actually equal to NB. So by using the line from the center, perpendicular to the chord, we'll bisect the chord. So AM is actually equal to 10 divided by 2, which is equal to 5. Alright, so by using the Pythagoras, we can say that the OM length is going to be equal to the square root of OA squared, which is the hypotenuse side OA squared, minus the AM squared, then you can get the OM squared, isn't it? So you can just write it down. The OM is going to be equal to the square root of OA squared minus the AM squared. So it's going to be the square root of 13 squared minus 5 squared, that's square root 144, then give you the length is going to be 12 cm. Alright, so that's for the first two questions. So let's go on to the third one. So for the third one, they're saying that in the figure, MN is the chord of a circle. We have the MR is 5, and NR is the 5 as well. So now we can say that MR is actually the same as NR. So now we have the OMR. OMR is here. OMR is 28 degrees. They're asking you to find out what is MRO. MRO is actually here. So that's MRO together with NOR, NOR, so the angle at the center. So we need to find out these two angles. So first of all, as MR is actually equal to NR, Let's give it from here. So that OR is going to be perpendicular to MN. By using our theorem, line joining the center to the midpoint of the chord is going to be bisect the chord, perpendicular to the chord. So that the IEO, the MRO is going to be equal to 90 degrees. And then if we consider about the triangle MOR, if we write it down, this is triangle MOR, we have this is 90 degrees, we have 28 degrees, and our required angle is this one. We can just, by using the angle sum of triangle, we can have the angle of MOR is this one, right? MOR is going to be equal to 180 degrees minus 90 minus 28. This one will give you, the answer should be equal to 62 degrees. So in question 4, we have M is the midpoint of AB. Midpoint means that AM is actually equal to MB. So now we have NOM. NOM is actually a straight line, and the angle NAO is 30 degrees. So first of all, we need to find out what is the angle of ANO. So it's very obvious it's a right angle, because we can using that as we have the AM is equal to MB by using M is the midpoint. So now we can say the line AB is perpendicular to NM. So that we have the angle of AMO is going to be equal to 90 degrees by using the line joining the center to midpoint of the chord is perpendicular to the chord. So for part B, we go to find out the angle of MAO. So in this question, you need to think about, if you want to find out this angle, which means that we have to find this angle as well, then we can using the angle sum of triangle by deducting 90 degrees, this angle, to find out the required angle. So now our question is going to find how to find out this angle. So if you look carefully, AO and ON is actually the radius, isn't it? So if these two lines are the radius, then this angle is going to 32 degrees as well, because we have the OA is equal to the ON, which is the radii. So that we have the angle of ONA is equal to the angle of OAN by using the base angles isosceles triangle. So that we can say that this is equal to 32 degrees as well. Then we can draw down the triangle. We can consider about the triangle A and N together with this small part O. Then this is 32 degrees, this is 32 degrees. So this is our required angle, and the angle of A and N finding from the part A is going to be 90. So by using the angle sum of triangle, we can have the required angle MAO is equal to 180 minus 90 minus 32 and minus 32. So now we have 90 minus 64 will give you the answer is going to be equal to 26 degrees. Alright, so for the last one, it's going to be a homework. So let's see, we have AM is equal to CM is equal to BN. This is equal to this. This is equal to this as well. All of them are 6 cm. So if the radius of the circle is 4 square root 3, so the radius is going to be the line joining from the center. It's not ON, okay? ON is not the radius. The radius should be OC. So joining from the O, the center, to the circumference is going to be our radius. So this is our radius, or because we know that they are the same, so we just erase them and we just want to focus on OC. So OC is actually equal to 4 square root 3. So as this two chord is going to be the same, so that this OMC is a right angle. So what we're going to find is the angle of MCN. This is the angle of MCN. So basically just means that the double of this angle, or this angle plus this angle. Okay, so by using the theory of the line joining center to midpoint of chord perpendicular to the chord, we're showing that this is a right angle. Similar for this B and O, is going to be right angle as well, because BN is actually equal to NC. Okay, so now we find out this is perpendicular which means that there's 90 degrees. And now we have the MC is 6 cm, and the radius is actually equal to 4 square root 3. Then we can actually using cosine. By using the cosine theta, we can find out what's the value here, right? So if we just consider about, before you construct the triangle, you need to write down something, because I didn't write down ON is perpendicular to OC. So first of all, you need to write as we have AM equal to MC, so that we have the OM is perpendicular to AC, so that we have the angle of OMC is equal to 90 degrees by using the line from the center joining the midpoint, joining to the midpoint of the chord will perpendicular to the chord. So that's the theory. And similarly, so you can do this similarly, you can say that the angle of ONB is equal to 90 degrees as well. So if we consider about the triangle of OMC, so we draw it down. So we have triangle of OMC, we have this triangle, isn't it? So this is ON, we have OMC. So angle of OMC is 90 degrees, and then we want to find out what is the angle of MCO. MCO is this one. So now we have the MC is 6 cm. You see, MC is 6 cm, and then OC is actually the radius, which is 4 square root 3. So then you can using the cosine, because the cosine theta is actually equal to the adjacent divided by the hypotenuse. So now we have the 6 is our adjacent because it's just next to the angle, and our hypotenuse is the line opposite to the right angle. So now we can just say that the cosine of angle OCM is equal to 4 square root 3 divided by 6. So I don't have a calculator right now, so try to use your calculator to finish that by using the angle of OCM is equal to the inverse cos of 2 square root 3 over 3. So just press the calculator, that you will get the answer. Alright, so the required angle is actually the double of the MCO, because the OCN and MCO are actually the same. So we can say that the angle of MCN, so that the angle of MCN is equal to the double of angle of OCN. Alright, so that's for this worksheet. Thank you.